Okay, so let us do the exam 3 review. And so this is on Blackboard, and what you can do is look at each one of the types of essay questions we're going to have. So in this first example, it's an aggressive data set. So we're looking at children's aggressiveness after they watched a TV show. And they measured the number of aggressive responses, and we have a known national average. So anytime you have a known average, that's going to be a single sample T on this test. And so we know that their average is 6.647. We're going to do the 6 steps of hypothesis testing and a one-tailed test. That's important to show if there's an increase in the number of aggressive behaviors. So we want the scores to go up, or we're testing if the scores should go up. So for step 1, we're going to talk about the assumptions. And so is the DV scale? I don't know what's happening. There it goes. Yes, it's a ratio scale. Because I could have 0 aggressive behaviors. Is it normal? I don't know. And N is less than 30, so I can't assume. Then the last one, I don't know what this, my computer's freaking out, but the last one is, were they randomly selected? Probably not. These children, random children, so probably not. Because I don't have access to all the children in the world, and I can't randomly assign. Because there's only one thing to assign them to. For step 2, we're going to write the research and the null. So the research, this is the TV show on the TV show versus the known aggressive behaviors. So the population mean. Yeah. Known aggression in kids. I can't spell. And then the null, we're going to do the same thing, this TV show. So that's what we're manipulating. We're changing about this group. Oops, wrong word. There we go. And the DV here is their aggressive acts. Okay. So we're seeing how much the TV show influences their aggressive acts versus a known level. Okay. We expect the TV show to increase them. So the null has to be decrease or equal to. So in step 3, we're going to list the sample mean, the sample standard deviation, the sample standard error. This is also listed as SM in the book, and S. Okay. And then N. And then over here, we're going to list the population mean, which it gave us in the problem, which is 6.647. So to do that, I need to pull up R. So here is my blank test. We're doing a single sample T first. My blank screen anyway. Let's click import dataset from text file. Find the file on your computer. It's review exam 1. Okay. The header has to be up there, so I get this in black. I'll just hit import. And so there are my 7 children for aggression, for the aggression dataset. So let's figure out the mean. So let's do a summary of the dataset. So here's my mean, 9.571. So that seems like it goes up. Let's get the standard deviation. Type up here. Okay. So the standard deviation is 3.87. The standard error is we're going to take that standard deviation, divide by the square root of the length. Right, remember length is n. Okay. So that gave us 1.46. It should always be smaller. Standard deviation is always smaller. Okay, and then we decided n was 7. But if you just want to check, you can do length. Okay, and that's where I got 7 from. All right, so that's the numbers I needed for step 3. Step 4, my degrees of freedom is 7. So let's go back over here. So for that, I'm going to do QT. The first thing that goes in QT is your p-value. So what did I decide? Is it 0.05? Yeah, 0.05. 0.05. Degrees of freedom. The degrees of freedom is 6. Derp. It is 7 minus 1. Sorry. So 6. And in this case, I want to do lower tail equals false because I want a greater than test. Greater than test means I need the top, so lower is false. If I wanted the bottom, lower would be true. Okay, so 1.94. Since it's a one-tailed test, there's only one side, so 1.94. Step 5, we have to get the t-value. We'll see if I can remember all this off the top of my head. So it's t.test, right? You're going to put in the column of data. Okay. Mu equals, and then the mu value. So let's go back over here. 6.647. Okay. Hi, puppy. You're really cute, but you got to get down. Okay. Let's see. We want to do confidence level is 0.95 because we're using a 0.05 test. And alternative equals greater. Okay, let's see if that runs. Maybe I've forgotten something. Nope, this looks good. Okay, so here's our t-value. Our degrees of freedom is 6, so I got that right over here. Okay. And then the hypothesis is that the true mean is greater than 6.647. So I did what I was expecting to do. Okay. And I got my mean as 9.571, which means it matches what I've been doing. So I'm really going to write down my t here, which is 2, essentially. So this is t found. It's 2.01 if I round up. So in step 6 here, do I reject the null? So is t found greater than t critical, which is this one? Okay. And yeah, it is. So we would reject the null. Okay. That TV show is increasing their aggression. I think it also said to compute effect size. Okay, so let's do effect size. So remember to do effect size and you'll get the script. You can just download it off Blackboard. I hid it in a folder, stuff to deal with. So this one, the scary one, yeah. So I'm gonna run that real quick so that I get all of my functions over here. And then we're gonna do d dot single. Okay. So the mean equals 9.571. U equals, for mu, 6.647. SD equals, we wrote this down, let's find it, 3.87. Okay. N equals 7. Alpha is 0.05, and leave K as 2. It gives me a warning, but that's okay. So this matches, my t value matches. Here's D, 0.76. So what does that mean? That's close to large. So the children's aggressiveness went up significantly, and it was a large effect. Okay, that's close enough to large, I found. Okay. So that is a single sample t-test. Let's move on to the second one. So anytime you see before and after, it's a dependent t-test. So let's see what TV does for applications. So if we do a whole bunch of criminal profiling shows, does that increase students' interest in forensic psych? So we're going to use popularity of a song, be affected by its appearance on like High School Musical show. So sales before the TV appearance and sales after the song is on TV. So before and after, it's going to be paired samples. This says to do a two-tailed test. So it might be that when you hear it on the TV show, you're over it. And everybody's like, tank this thing, I'm over it, it's done. Okay. Now, obviously, you would expect it to go up, but it says very clearly here to do a two-tailed test, right? And then here it says affected by its appearance, so it doesn't really give me a direction. Naturally, I would think it would go up, but here they want us to do two tails. So let's do that one. Oops, let's do that one up here. Wrong thing. So first thing I'm going to do is import the data. That's example 2. Okay, so that's what that looks like. And then let's start here. So compute the paired samples T, make a decision. So this is going to be 6 steps. So step 1 is the same steps. So is the DV scale? Yes, it could sell no albums, so it is totally ratio. Second one, is it normal? Don't know. N is less than 30, so can't assume. Did I randomly select? I guess we could find most of the songs that are on the show versus not on the show. So I guess yes, you could. You could. So for step 2, remember this one's a little weird. So we're gonna write the research is we can do before minus after or after minus before. It actually doesn't matter since we're doing a detailed test. But generally people do difference of after minus before, because then positive numbers mean goes up. Okay. And that's compared to no differences expected. Okay. So difference of after minus before, and then no difference expected. So when you say no difference expected, what you're saying is that mu is 0. So the difference is not equal to no difference, and the difference is equal to no difference for the research and the null. Okay. For step 3, what we want to do is list the mean difference, the standard deviation of the differences, the standard error of the differences, and n. And out here, we're assuming mu m is 0. Okay. So let's find those. So first thing I want to do is find my difference score. So I'm going to do after minus before. So okay, this is the second question. I'm going to do after minus before. Okay, hit enter. So that gives me my difference score. And now I can run some of the same ones. So summary of the difference to get the mean difference. Puppy. Okay. Maybe I should leave this alone. Right? So the mean difference is a negative 0.2. Okay, if I did after minus before, that means it's actually going down. So that's not good. Right? And then, so it looks like 3 of them are going up, but this one is definitely going down. Okay. So their sales are actually getting worse. That's no good. Okay. We can do SD of the difference to get the standard deviation. So it's 1.14. The standard error of the difference would be the same formula we did a minute ago. So standard deviation of the difference divided by the square root of the length of the difference. So you notice how I'm doing this on the difference scores and not the individual scores. So 0.57. And then n is the number of scores. So length. Remembering that this is dependent t. So there are 8 total scores, but only 4 people or 4 songs in this study. So n is 4. So for step 4 here, we're going to go 0.05. Right? Here's 0.05. And then our DF is 3. We're doing P less than 0.05. We're doing a 2. You don't have to write this. I'm just writing it out so you can see. Two-tailed test. That's the important part. So for our code here, we're going to QT 0.05 divided by 2 to get both tails. Degrees of freedom 3. And lower tail is false. So it's plus and minus 3.18. But if you aren't sure, there's the minus. Okay, so for a two-tailed test, it's plus and minus 3.18. So in step 5, we need to do T found. Ooh, I am fond of T, but not today. There we go. So for T found, what we're going to do is T.test in the same order. So after, then before. So review, it does after, and then, so do whatever order you pick to do them in the same order. Before. We've got paired equals true. That's important. That needs to be in there. Confidence level is 0.95. Alternative 2.cited. So make sure it says paired T. If you forget this paired thing, it's going to look like this. It's going to say Welsh two-sample test. So be sure it says paired T equals true. It says our t-value is negative 0.35. Our mean difference score is correct. Good. True difference is that they're not equal to 0, right? So that's the difference in means, so that's why that's on the left side. Not equal to no differences. So our t is negative 0.35. So in step 6, I'm going to fail to reject. There are no differences. The other thing it asks for is confidence interval and Cohen's d. Since I did this as a two-tailed test, the confidence interval is right here. It says 95% confidence interval. But I can also look at the d formula and do that. So I have my d's loaded over here. So d dot dependent t. You can do diffs here, sorry. So mean diff is, that's the scores we have over here, negative 0.20. SD diff is 1.14. Okay. N is 4. Alphas 0.05. K equals 2. So my D value is negative 0.18. But here's my confidence interval again. Negative 0.20 to 1.61. So it's the same thing as here. So but my D is negative 0.18. So it's a really small effect. We didn't reject and we said, oh, that's a tiny effect. Okay. The confidence interval also includes 0 in the middle. So just another confirmation that we shouldn't have rejected the null. Okay. Did I do everything? Yeah. All right. So the third one. This is that men and women study that we've looked at actually a couple times to make graphs and to do these different things with. So now we're going to do hypothesis testing, but use p less than 0.01. Okay. And is there any notion that women talk more than men? All right. So we're actually asking, a one-tailed test. Step 1. Is the DV scale? Yes, it's ratio. I could talk no words a day. Is it normal? Don't know. N is less than 30. Man, can we not get a big enough sample? So can't assume. Can we randomly select? Oh boy, no, can we not? No, because we don't have access to all men and women. Can we randomly assign? That's a big no as well. Okay, I can't assign you to be a different gender. Remember the other one is homogeneity, and we're going to look at the standard deviations. So we're actually going to come back to that one. Research is that women speak more than men. The null is that women speak less or equal to men. So remember, they have to be opposites of each other. And I'm going to keep my men and women columns equal here. Or on, I should put my women on the left side. So for this section, if you want to make a little chart. Okay. So I've got women and men. So let's get the mean for each group. the standard deviation for each group. So we can do homogeneity, N for each group, and then we're going to get S pooled and S difference. And now I'm going to copy that from my R script, because while I know it off the top of my head, blah, right? It's not the easiest thing in the world. So you'll be able to use this R script thing here. Okay. And we're going to copy S pooled and S difference right here. So we'll come back to that in a minute. Okay. So first thing I need is the mean for each one. So import from text file. Number 3 here. It's got men and women. Let's make sure this came through correctly. Oh no, it came through as a factor. Lame faces. Those should be numbers. See how they're left aligned? So let me fix that real quick. I had this open. I think we've had this issue with this data set before. The commas are freaking it out. Right. So Excel thinks it's a number. But let's make it a number for real. There we go. I'm going to save it. So I highlighted both columns. Here in the middle I picked number, then I just saved it. Let's see if that fixes our import problem. Yeah, look at that. Now, if I look at 3.3, they're both numbers. That's much better. All right, let me do something real quick. Put that on. There we go. So now I can take a summary of my third question. So the mean for women is 16,201. Oops, wrong column. Or wrong spot, rather. The mean for, close this. For men here is 15,989. Let's do the standard deviation of each column. So remember, mean 1 equals 16,201. Mean 2 equals, we did this in class, 15,989. And we want to do SD1 equals standard deviation of our data set. $, let's go women. And then print that out so I can see it. It's a big number, 1,700. And then let's do SC2 equals and then print it out. So 2,200. Now I can answer that question about homogeneity. I'd say those are roughly equal. 1,800 and 2,200. They're both big, and I'd say it's roughly equal. Let's do N. So I'm going to do N1 equals length women. So let's see what N1 is. 5. N2 is probably also 5, but remember, this has a purpose. If you don't remember, we'll get to it in a second. Okay. N2. There we go. So 5 and 5. Excuse me. I've got all my stuff here. So that makes degrees of freedom 4 for group 1 and 4 for group 2. So the total degrees of freedom is actually 8 because you add them together. But remember, we saved them all as M1, M2, and all this trouble because then now I can cut and paste that formula, which from my sheet, which has S pooled equals on here twice. Let's take that off. And just run this code. Okay. So let's see. S pooled is 2017. So it should be a weighted average, and since they're equal groups, they're pretty much the same, so it's just an average of these two. S difference, or standard error of the differences, is, oops, R's and E, 1275. So S pooled is the denominator for Cohen's d, S difference is the denominator for t. Of course, when I'm trying to record this review, the little beagle dog is like squirrely as all get out. So she's in a good place, in a good house to be squirrely, right? All right. So now that I have, I think this is everything for step 3. Let's start talking about finding t critical. So we're using p less than 0.01 because we don't want to make this claim unless it's really unlikely that they speak the same. But as a one-tailed test, okay, it's a greater than test in our example. And then, what am I forgetting? Oh, degrees of freedom equals 5 minus 1 plus 5 minus 1, which is 8. So it's n minus 1 plus n minus 1. So let's go back over here. So we're going to use QT 0.01. 8 lower tail is false because I want to see if women are greater than men. So I get 2.89 or 2.90 if I round up. Okay. And so that means that we have to get at least 2.90 on our t-test for it to be significant. So let's run that t-test. So I'm going to come over here. We do t.test. We're going to do women first since we put women first in every other spot. So, plus, of course, right? I'm partial though. Women, then men. Okay. Paired equals false because this is an independent t-test. var dot equal equals true, so that because that's a homogeneity thing. Confidence level equals 0.99. And then brain fart. Oh, alternative equals greater. So our means look correct, so I've done something right. So you can always kind of match up. This rounded up, and that's okay because that's how it showed it to me. My t is really small, so 0.16. Degrees of freedom are 8, so I did this last step correctly. And what happened is the difference in means is greater than 0. So the difference between women first minus men is greater than 0. So that is kind of the idea that the mu here is still 0, although we're not really using mu. Now, in step 6, I am going to fail to reject because my t found is not greater than t critical. Okay, so I'm going to fail to reject. It does not ask for confidence intervals on this example or Cohen's d, but let's go ahead and do it just so you can see what it looks like. Now, what you want to do is get the confidence interval of the difference. That's the important part. Like, that's the thing the book asks for. Now, I have this test, and it gives me this confidence interval, but it's got this inf thing for infinity. So what I'm going to do to get a two-tailed confidence interval, just copy my t-test code, cut and paste it exactly the same, leave this alone, and just change this to 2.cited. Okay. And then there's the confidence interval of the difference. Look how big it is. It's huge. So 0 is right in the middle. So the mean difference is most likely somewhere between 4,000 for men and 4,000 for women, with 0 right in the middle. So no wonder we didn't reject. If I wanted to get Cohen's d, what I could do is type d dot independent t, that one. And remember, we wrote out all of them. So mean 2 equals mean 2, SD1 equals SD1, SD2. Look how much easier this is. N1 equals N1, N2 equals N2. Okay, here's the fun part. A equals 0.01 in this example. K equals 2. No, not 5. So I got the same t-value. I know I'm doing something right. I got the same means. It just rounded up. And then I got my same standard deviations. But here's Cohen's d, 0.11. So no wonder it didn't work. All right, last but not least, the dreaded ANOVA. This is kind of a complicated, or a big one. So we've got 4 groups, which is a little different than what we've done, but we'll walk through it. So we're trying to see if these different remedies are effective at relieving allergies, and if so, which ones are the most effective. Okay, so we've got 20 allergy sufferers. We're so close to 30, but oh no. They did randomly assign, so that's a good sign. Okay. And then they complain how many allergy complaints they had. So we want to use 0.05 and then figure out post hoc. Okay. So for step 1, we've got 4 assumptions. Is the DV scale? Yeah, it's actually ratio because I could have 0 complaints. Is it normal? Oh, so close. Don't know. N is less than 30, so can't assume. So you can see why 30 is, a lot of researchers really strive to use 30 because it's the magic number. Did they randomly select? Probably not. Okay, but they did randomly assign. Okay. And then homogeneity, which we're going to have to look at the means, standard deviations to get. So for step 2, the research is T is not equal to homeopathy. It's not equal to the antihistamine. Why are these all so hard to spell? Right? Which is not equal to placebo. And the null is that they're all equal. So I'm going to copy that. That was too many hard words. Right? Homogeneity ruined me. I don't want to type the rest. There we go. So it's always equal to and not equal to because this is a two-tailed or a folded over test, right? So we can't ever have negative numbers, so it's kind of hard to do the less than test. Okay. So for step 3, this is the big one. First thing we want to do is list the means. So let me load that data set. This thing. Great. And we're just going to take a summary of the data set. Now I'm just going to cut and paste it. That's so much quicker. Ready, go. Okay. So my means for each group are here. Okay, so 2, 2, 2, 5. So it looks like all of them might be working because remember scores that are lower, this is allergies, are better. Then we got to do all this hard work. We're going to get the standard deviations so we can check our homogeneity assumption. So we're going to do SD of the review for T, SD of the review of homeopathy, antihistamines. And then nothing, these poor folks. They just got pills. Sugar pills. So here are my standard deviations. And they're okay, I would say. So I got 0.8, this low one. This is 2 times the small one here. So you could go either way. I would take either answer. You could say they are all small and okay. Roughly, oops, equal, or you could say no, one is 2 times larger than another. So that's an example of like both of those answers might be correct. Just be sure you tell me why on this one since it's a new assumption for this test. All right, then the dreaded ANOVA table. So let's see, I've got let's do sum squares, degrees of freedom, mean square F. So between, one more row. between. That's my IV. I'm within. That's my error. My total. We've got sum of squares, degrees of freedom, mean square, F. Now to do that, we've got to set this up. So first thing I'm going to do is load the reshape library. And I'm going to melt the data. So I'm going to restructure the data into a different format. So we're going to do long data, there we go, equals melt dataset name, review, ag. Measured equals, and then the names of the columns. So I'm going to click here and just look at how they're spelled, so I spell them correctly. I can spell today. There we go. So it gave me my using ID as variables, that's fine. I'm gonna click on 3.4. No, I'm not. I'm gonna click on long data just to make sure. It looks like all 4 groups came through. Woo! Now I'm gonna add a participant number. Now don't forget, I'm gonna go over to my script here. You can actually copy here. I added an extra line of code to your script just to make sure that we wouldn't have any issues. So I'm gonna run both of those. This just omits any NAs, so in case Excel imports kind of funny. And then you can copy all of this too. So you don't have to remember this off the top of your head. So we added a participant number by doing the one to n row thing. So look, now I have a participant number out here. We'll load the EZ library. Data equals long data. DV equals value, because when it melted the data, it changed everything in the DV, every one of the allergy scores into value. Between equals variable, that tells me what level group I'm in. Within subject's ID is participant number. Type 3, return AOV equals true, so we get all of the data we need. Gave me a little grumpy warning, but that's okay. It ran, whoops, wrong one. So for my sum of squares, I'm going to use this piece here. So I got 4375 and 3880. And then I can just add those going down. So 4375 plus 3880 equals 8255. Okay. My degrees of freedom I can get from the same place, 3 and 16. So it's 4 minus 1. And then 5 minus 1 plus 5 minus 1 plus 5 minus 1, one more, plus 5 minus 1, so 4 times 4. And then I also get F. F is here. Okay. You also get your degrees of freedom again, but here's F, 6.01. If I wanted mean square, I would just divide going across. So let me open up the calculator here. I know I can use R, but I'm in an easier window. So 1458. Can at least do this. So 3880 divided by 16, 2.42. Quick check is 1458 divided by 2.43. 6. We're good. Because remember, nothing goes here. So you kind of do everything, and then you check to see if it's significant. So step 4, our p-value is less than 0.05. Our degrees of freedom are 3 and 16. So let's see what that looks like. So QF, because it's the F test, 0.05, 3, 16, lower tail is always false. So I got 3.24. F critical is 3.24. In step 5, I'm going to do F found. And I just figured that out from my table was 6.01. In step 6, I'm going to reject the null. Da, da, da. Effect size, what it is it is 4375 over 8255. So where's that calculator? So I can do 4375 divided by 8255. So I got 0.53. Or come down here to GES, it's this thing. So 0.53, it's a really big effect, so r squared equals 0.53, which is large, large, large. And then the last thing it tells you to do is the post hoc test. So with ANOVA, if you are working on it and you can't remember post hocs, remember they're scored based on like how many pieces there are to the question. So this obviously is a lot longer than some of the other questions. And so even if you only get through A and B, you'll get partial credit for finishing A and B. So let's see here. So figure a post hoc test to determine where the group differences lie. Right. So let's see here. I'm going to make myself a box. Mean 1, mean 2, P, explain, reject. So I am going to have a lot more of these than 3. To run this code, what we do is pairwise Ttest. We're going to use long data. Oh, actually, JK, let's copy it. Wait, it's down here at the bottom. Shrink. Just gonna copy. But you would do DV first. Okay, so make sure your little quotes copy for Bonferroni correctly, but it's pairwise data, so long value, so you do DV, comma, IV, which is the same way we did independent T. Paired equals false, because this is independent T. So remember all this right here, independent T, plus the correction. Bonferroni on the top. That gives us 1, 2, 3, 4, 5, 6 comparisons. Not that window. This one. Wrong thing. Copy. Alright, so let's do this. So we've got T versus Yo. There we go. And so the p value is 1.00. That's no good. And then I've got T versus the antihistamine. And then T versus the placebo. Okay, that's 0.03. And then I've got homeopathy versus the antihistamine. That's 1.00. Same thing versus the placebo, 0.01. Last but not least, the antihistamine, since it's everything by everything else, placebo, 0.02. Our p-value from step 4 is 0.05. So that's the same for all the columns. That's alpha. So is 1 less than 0.05? No. So fail to reject, groups are equal. In the second one, that's also true. Groups are equal. This one I'm going to reject. Who has the lower mean? Well, I'll have to figure that out in a second. This one I'm going to fail to reject. This one I'm going to reject. This one I'm going to reject. So now let me go back and pull my means, which we had up here. I'm just going to copy them down here real quick so I can see them. So her herbal tea is 2.2. The homeopathy is 1.8. Antihistamine is 2. And the placebo is 5.4. Those poor placebo people. So when I reject, here what am I saying? The T has less allergy symptoms than the placebo, which is good because that's what you want, right? Homeopathy group has less allergy symptoms than placebo, right? And the antihistamine group is doing better than the placebo. So if I had to create an overall picture of this experiment, what I would say is that it doesn't matter which thing you do, just do something. So the tea and the homeopathy and the antihistamine were all useful at reducing symptoms over a placebo, over nothing, but they're not different from each other. And so there aren't any differences in the type of, up here, the type of remedy, but they are better than nothing. And so that is how you would work the exam 3.